Agenda. In this short video, I'll discuss the following topics. Topic number 1, I'll discuss the concept of range, interquartile range, variance, definition of standard deviation, coefficient of variation, z-score, and how to detect outliers. And the last one is optional. Chebyshev theorem. Topic number 2, I'm going to generate simple value like 5 to 10 value to estimate variance standard deviation. I'm going to show you the key concept of variance is squared deviation. We are going to estimate variance standard deviation and other measures manually and also using Excel function. And also I'm going to discuss based on the sample and based on the population. So .S is for sample, .P is for population. Topic number 3, z-score, how to detect outlier, and Chebyshev theorem. Topic number 4, we are going to use a mutual fund data supplied by the author to estimate various statistics. Topic number 5, using SP500 data to calculate variance standard deviation and z-score. And the key is we use z-score to standardize our data.
Shutterstock Music. Shutterstock Music.
Next, we are going to calculate a range. It's defined as largest value minus smallest value. And also we calculate interquartile range. IQR3 minus IQR1. Okay. First, so let's randomly enter some values. Okay. You can enter your own values. Then the last one we enter -4. Okay. So we enter some values. We are going to calculate range and interquartile range. Okay. And also the largest value we can use max to calculate largest value and use minimum to calculate smallest value. Okay. Then we apply Excel max. We enter the data range. So max value is 12. I'm going to use show formula to show the cell D2, the formula in D2. Just make it a little bit bigger so everyone can see it. So I applied equal max A2 to A9. Okay. Now we can calculate minimum value. Okay. The smallest value we apply the function of MIN. So it's minimum. We can also use show formula to show exact formula we used. The range is simply the maximum value minus minimum value. So equals D2 minus D3. So I simply manually enter D3. Okay. Then I copy the formula, show formula, and it's simply D2 minus D3. Okay. Alternatively, we can just enter 1 equals maximum value minus minimum value. Then maybe this, when you become good at Excel, then you can save many steps. So we have exact same result. So copy the formula, maximum value minus minimum value. Okay. So next one, we calculate the third we calculate interquartile range. Okay, interquartile 3, interquartile 1, first quartile. So we can use Excel function called quartile.exe. We enter the first input variable is range, data range. The second one will be 3 because we're interested in interquartile range is defined between third quartile and first quartile. And again, we use show formula to show the formula used. For the next one, we apply the same formula. Quartile.exe, and the first input is data range. The second one is 1 because we're interested in first quartile. Interquartile is simply third quartile minus first one. Actually is the data set, the middle 50%, the range of the middle 50%. So interquartile is simply the first one minus the last one. Sorry, the third one minus first one. Make it a little bit bigger. So again, let's review. So range is largest value minus smallest value. And also we can put them together. You see the first one is 16 and the second one is 16. For interquartile is we apply the formula, we calculate the third quartile. Next, we are going to calculate standard deviation variance and the standard deviation. Again, we randomly enter some values. Actually, we enter exact same value as before. Okay, and you can enter your own value. Okay, the first one usually I calculate how many observation. So it's n equals we can use count, enter the range, and we close is 8. Okay, there are 8 observation. Again, here I use show formula to show the formula in cell E2. Just make it a little bit bigger. And okay, the next one is we calculate mean because in the formula we have to calculate deviation. We apply average, Excel averaged to calculate the mean. Again, mean is 3.25. Okay, just make the formula available, make it a little bit bigger. Okay, count, calculate n, average, calculate mean. Okay, so look at the first squared deviation. The key is squared deviation. So let's calculate deviation. So deviation is x1 minus mean, x2 minus mean, continue this way. The first deviation is 1 minus 3.25. So it's negative 2.25. We fix the mean before we copy and paste. Then we copy and paste the formula. Okay, so x1 minus mean, x2 minus mean, x3 minus mean, until the last one minus mean. Okay, again, you can manually check one or two values. Okay, Suppose 0 minus 3.25 is negative 3.25. Okay, according to the formula, it's a squared deviation. So deviation times itself, or you can use square. So it's negative 2.25, it's positive 5.0625. Then we copy paste the formula. The summation will be numerator, right? The numerator will be the summation. So I enter sum. Summation divided by n is variance for the sample, for the population, if divided by n minus 1 for the sample. Okay. So this is divided by, this is summation. Okay, the summation, let's enter some value here. Okay, so this is show formula. So actually it's B9 times B9. It's squared. Okay. Summation is simply summation from C2 to C9. See, sum from C2 to C9. Okay, so this is sum. Okay, so variance based on the population. Okay, based on the population is summation of squared deviation divided by n. For the population divided by n, for the sample divided by n minus 1. So variance for the population, sorry, should copy the formula in D11. So this is C11 divided by E2. Is simply summation of square deviation divided by n. Next one, we can use Excel variance P. P stands for population. So this is much easier. We highlight our data, then we will get exact same result. So let's copy the formula in we can manually calculate, and in the future it's much easier to use Excel function. So variance for the sample is simply the summation divided by n minus 1. N minus 1, so E2 minus 1. Because the denominator is smaller, so the variance for the sample is always higher than variance for the population. This is true for the standard deviation. Okay, it's C11 divided by E2, C11 divided by E2 minus 1. So 1 is divided by n, the second one is divided by n minus 1. Alternatively, we can use var.s for the S stands for the sample. Then we have the exact same result. So actually there's another function called var. Let's know .s or .p. So let's test. It stands for p or s. So it's the same as var.s. So var is same as var.s, stand for the sample. Next one, so let's look at standard deviation. Standard deviation, it is square root of variance. So we can manually calculate. Usually we don't need to manually calculate. It's variance for the population, square root of the variance will be standard deviation. Okay, then we can use the show formula. So SQRT stand for square root. Okay, square root of variance is standard deviation. Alternatively, we can use stdep dot p. Again, p here stands for population. We enter the data range. Then we have exact same result. Okay. So manually we know how to calculate, and it is much easier to use Excel function. Okay. The first one is we square root of variance for the sample, and we can use power 0.05. Okay. It's same thing as square root, SQRT, same thing as power of 0.5. Okay, we're going to show the formula. Okay, it's variance raised power of 0.5. It's much easier to use stdv.s. Again, here S stands for sample. Then we have the same result, 4.832923. Okay, stdvs.s. There's another function called stdv. Then we enter all the data set, we have the same result. So this means stdv is same thing as stdv.s. Next, we are going to get the data from R. We type .get data. So .a, .b are two functions we can use, .csv and .txt. So let's try the method 1. Is we are going to have to get a mutual fund data. .a mutual fund. Then data ID is 70. So we use .b 70. Then we can launch Excel and paste. I call this method 1. Launch Excel, paste it. So let's look at method 2, use CSV file. To get the link of CSV file, it's mutual fund. We type mutual again. And we can, so this is link. We can download a CSV file, then use Excel to retrieve it. So the first one is the data we are going to use. So this is a CSV file. So let's look at the txt file. It's text file. Again, the first one will be the data set we are going to use. And I'm going to use method 3. Use txt data. And so we type .txt. We enter mutual fund. So this is our link. If you are not taking my course right now, you can use this link to get the data. So we go to a web page and we paste it here. I'm going to use new one. Okay. We paste. And so this is our data. Okay. You see, the only we have like 10 observation and also return. Okay. We can save it to a text file. Okay, if you want to save it, so we can save it. Suppose I go to ctemp, I can save there. Then I can use Excel to retrieve it. I'm going to do both. Okay. Alternatively, because it's a small data set, I can simply copy and launch Excel, and I can paste it. Okay. For my computer, something's wrong. Okay, something's wrong, and then I'll go back. But here, I enter another called the 2. Okay. Another 2. Enter. Okay. You will not see the difference. The difference is we have a blank in front of each, the first one. So let's copy and we go to, okay, so let's paste it here. Let's make it bigger. So something's wrong here. Okay, so let's paste it here. Okay. And so this is correctly copied. Okay. And we should have 2 columns. Actually, this is 1 column. So we click data. So this is text 2 columns. Okay. We choose the first one and choose space. So after we choose space, and it becomes 2 columns. So that's finished. So this should be here. Now we have our data. Okay. Now we have our data. So actually we have 2 columns. First column is year. Second column is return. Okay. Obviously there are some issue here. Is negative 22. Should be negative 22%. So everything divided by 100. Actually, I hate this kind of expression. Okay, so this is much better. The first one is negative 22%. The second one is 28.7%. Okay, we are going to calculate the mean, calculate variance for the population, standard deviation for the population, and also variance for the standard deviation for the population, and the standard deviation for the sample. Okay. In addition, we are going to calculate the z-value. Okay. The first one, we calculate mean. Okay. And so first one, let's calculate count, calculate mean, calculate variance. So variance for the population. So based on formula. Okay. Variance for the population. Excel, we use var.p. Okay. Then we calculate standard deviation. So standard deviation for population and standard deviation for population based on Excel. Okay. Exact same thing. We calculate for the sample. Okay, for the sample. Okay, for the sample. Okay, sample and for the sample. Okay. Manually calculate, trying to help you to understand the formula. Okay, I'm going to post the formula here. Okay, so we use count. Even we know it's 10, right? Count, and we count all the return. So we have 10 return or 10 observations. I'm going to use show formula. Okay, we show formula here. So we know it's use count. Okay. The mean, we use average. So we use average. Average. Okay. Then I copy paste the formula here. So we use average. Okay. And for the variance for the population, as I mentioned, the most important is squared deviation. Okay. Then we calculate deviation. So deviation is defined as return minus its mean. So this is called deviation. Okay. I'm going to use show formula. In the future, I'll show you how to make this VBA available for you as well. You see, it's very, very convenient. You see, this is D2, its first return. J3 is mean. It's mean value. I'll make it red. Okay. So this is mean. Okay. Before we copy and paste, we have to log J3. So $J$3. So we hit F4. Enter. You see here is $J and $4. Then we copy and paste. If you can just copy the formula. So copy the formula. Okay. You see D2 minus J3. So D2 minus mean, D3 minus mean, D4 minus mean, and continue this way. Okay. So here is deviation squared. So actually deviation times deviation is called deviation squared. Okay. So equal, so deviation times itself. So just copy it times. Okay. So let's copy and paste. Okay. So if you want to show the formula, show formula. So it's simply the deviation times itself. Okay, then we have summation. Okay, so this is summation. Okay, summation of all squared deviation. This is numerator, right? So this is numerator. And it's simply summation. Okay. So let's calculate variance for the population. Remember, the variance population will be summation. Total summation divided by n. So this is n. So this is our variance for the population. The summation of squared deviation divided by n. Okay. Alternatively, we can use var.p. Divided by n is for population. So we can use var.p. Then we highlight our return. Then we close it. We got exact same result. Okay. So first value depends on our formula. The second value, we use Excel function var.p. Okay. And standard deviation equals SQRT, square root of variance. Okay, so this is, we use square root. So we use square root. Alternatively, we can use STDEV.p. because it's related to the population. Again, we highlight of our return column, we enter, then we have same result. Okay, so here the first 19.454 we use square root of population. Square root of variance. The second one we apply standard deviation for population. Okay, and again variance for the sample. Okay, so equal. We apply the formula. Summation divided by n minus 1. So actually it should be 9. N minus 1. So this is variance. So this is summation divided by n minus 1. So J2 is n minus 1. Okay. Alternatively, we can use var.s. Then we enter our return range. So this is return. Okay. Then we close it. So this is the second way to calculate. Okay. And standard deviation equal SQRT. Standard deviation is square root of variance. Okay. Alternatively, STDEV dot S. So this is standard deviation for the sample. Okay, so this is after we calculate variance, we can use square root. And for this one, we simply calculate it directly. Okay. Another function called STDEV. There's no dot P, there's no dot S. Then we put everything inside. Okay, then we have same result. Okay. Okay, so next one, oh, I don't have, okay, so let's put it here. So let's call it Z. So what is a Z? Z, we can think it is standardized data. Z is our value, original value minus mean divided by standard deviation. Okay, so Z equal our return minus mean divided by standard deviation. So this is our function. Okay, so here we use equals left parenthesis. So this is first return. So first return minus mean closes divided by standard deviation. So usually we use standard for the sample. Okay, I'm going to make it here and show formula. Okay, if you look at the formula, J3 is mean, and J11 is, so let's look at J11 is standard deviation. Okay, so before we copy and paste, so we have to log J3, J11. So we move cursor here, we hit F4 twice, then F4. So this is our formula. You see the D2. The D2 is our return. Okay. Return minus mean divided by standard deviation. Then we copy and paste. We copy and paste. Okay. And because we know our mean is 5%. So anything above 5%, suppose, let's look at this value, is above 5%, then we will have a positive value. Okay. So anything below mean, we have a negative value, and anything above mean, we are going to have a positive value. Okay. And that's it.
Shutterstock Music.